Hello friends, welcome to Bindu Dhadwal Chemistry lessons. The topic that we do today is halogens group 17. The elements of group 17, fluorine, chlorine, bromine, iodine and astatine are called halogens. The word halogen means, halo means salt, gen means genesis, so formation of salt or salt producers. These elements are generally found in the form of salts in oceans and sea water, so they are called halogens. The atomic number fluorine is 9 and electronic configuration for fluorine is helium 2s2 2p 5. So halogens have general electronic configuration ns2 np5. They have 7 electrons in their outermost shell. Chlorine, neon 3s2 3p5, bromine, argon 4s2 3d10 4p5, iodine 53 krypton 5s2 4d10 5p5, and astatine 85 is xenon 6s2 4f14 5d10 and 6p5. Occurrence: fluorine occurs in the form of fluoride compounds like fluorspar, cryolite and fluorapatite. Fluorspar is CaF2, cryolite is Na3Al(F6) and fluorapatite is 3 calcium phosphate, calcium fluoride. The elements chlorine, bromine, iodine are formed as salts in seawater, and iodine salts can be found, iodine concentration is found in seaweeds. Astatine is a radioactive element. Physical properties: atomic radii. The atomic radius of group 17 elements is smaller than that of group 16 due to more effective nuclear charge. Smaller size and higher nuclear charge makes them smaller. Down the group, the size goes on increasing due to increase in number of shells and increase in shielding effect. From chlorine to iodine, the increase is small because the D subshells cause poor shielding effect. Ionization enthalpy of group 17 is less than group 16 elements because they have smaller size than group 16 and have high effective nuclear charge. Down the group, the ionization enthalpy decreases due to increase in size and shielding effect. Electronegativity or non-metallic character. Elements of group 17 are highly electronegative due to small atomic sizes, and they need only one electron to acquire a noble gas configuration. Fluorine's electronegativity value is 4, chlorine 3.2, bromine 3, iodine 2.7, astatine's electronegativity value is low, 2.2. So because of high electronegativity, these act as non-metals. Astatine, having low electronegativity, is a radioactive metal. Down the group, electronegativity decreases due to increase in size. Electropositive character is the reverse of non-metallic character. So group 17 are less electropositive than group 16. They have smaller size than group 16. Down the group, the metallic character increases due to increase in size. Electron gain enthalpy. The amount of energy released when element gains electrons is called electron gain enthalpy. Element of group 17 gains electron to form a negatively charged halide ion and releases energy. The electron gain enthalpy of chlorine is higher than that of fluorine. Though elements of halogen group, they have high electron gain enthalpy because of small size, and they need only one electron to complete their octet, yet the electron gain enthalpy for fluorine is less than that of chlorine. This is because the fluorine's atom is small in size, and when the electron is to enter the outermost shell, it faces inter-electronic repulsion. Whereas in chlorine, the size is bigger, the impact of nucleus is less, and there is less inter-electronic repulsion. So you can see that electron gain enthalpy values for fluorine is -333, which is less than chlorine, -349. And down the group, the electron gain enthalpy values again decrease because of increase in size of the atom. Oxidation states. The common oxidation state for halogen family is -1, as they have 7 electrons in their outermost shell, and only 1 electron is needed to complete the octet. All the elements show -1 oxidation state. Fluorine shows +1 oxidation state in OH negative, F positive, but otherwise it does not show +1 oxidation state or any other positive oxidation state because of absence of d orbitals. Whereas other members, chlorine, bromine, iodine, can show +1, +3, +5 and +7 oxidation state due to presence of vacant d orbitals. So in the ground state, the electronic configuration is Ns2 Np5. Now, fluorine does not have d orbitals, but other elements have d orbitals. So in the first excited state, one of the paired electron may jump to d and acquire this configuration. There are 3 half-filled orbitals, so it can show up an oxidation state of +3. Similarly, in the second oxidation state, along with this electron also jumps to d subshell, which is vacant, and as a result there are 5 half-filled orbitals, and it can show +5 oxidation state. If the s electron also jumps to the empty d orbital, then there are 7 half-filled orbitals, and it can show +7 oxidation state. Down the group, the +7 oxidation state becomes unstable, but +5 becomes more stable due to inert pair effect. In higher oxidation state, these elements behave as oxidizing agent, whereas in lower oxidation state, they behave as reducing agent. And in the middle oxidation states of +3 and +5, they can act as both oxidizing agent as well as reducing agent. Fluorine is the strongest oxidizing halogen, and it oxidizes other halides in solution or even in the solid phase. In general, a halogen oxidizes halide ions of higher atomic number. For example, fluorine can oxidize halide ions like chloride, bromide and iodide, and get converted into fluoride ion, and halogen will also be formed. Chlorine can oxidize the halide ions which are present below it. For example, bromide and iodide into halogens. Then bromine can oxidize iodide ions into iodine. The decreasing oxidizing ability of halogens in aqueous solutions down the group is evident from their standard electrode potential values, which are dependent on parameters. First, the electrode potential value 2.87, 1.36, 1.09 and 0.54 electrode potential value is decreasing down the group. This value depends upon 3 factors: enthalpy of dissociation, enthalpy, electron gain enthalpy, and enthalpy of hydration. A halogen from molecular gaseous state has to be converted into halogen atom in gaseous state. For this, enthalpy of dissociation is needed. This gaseous halogen atom then gains electron, and electron gain enthalpy is released. This negatively charged halide ion then gets dissolved in water, and enthalpy of hydration is released. The relative oxidizing power of halogens can further be illustrated by their reactions with water. Fluorine with water forms hydrogen ions, fluoride ions, and oxygen gas. The halogens chlorine and bromine, they form hydrogen halide and hypohalous acid, whereas iodine cannot oxidize. It simply reacts in reverse of fluorine. In case of iodine, iodide ions are oxidized into iodine gas. So another thing is that even though fluorine has less electron gain enthalpy value than chlorine, yet fluorine is the strongest oxidizing agent. This is because the overall effect of these three parameters, the dissociation enthalpy, the electron gain enthalpy, and hydration enthalpy value, gives more negative value for fluorine than for chlorine. Next property is color. All halogens are generally colored. Fluorine is light yellow, chlorine is greenish yellow, bromine is reddish brown, iodine is dark violet. Now this color results due to absorption of radiation in the visible region by molecules. The electrons, valence shell electrons of the halogens, they will absorb energy incident from visible radiation and jump to higher oxidation state, but as they are unstable in higher oxidation states, higher energy levels, they will fall back to lower energy levels, releasing energy in the form of visible radiation. As fluorine's ionization enthalpy is very high, so it absorbs energy of higher energy. It absorbs higher energy radiations like violet and thus give a pale green color. And on the other hand, the ionization enthalpy value, because of large size of iodine, is less, so it absorbs low energy radiation and gives dark violet color. It is elemental state. Halogens exist as diatomic molecules due to small size and presence of 7 electrons in their valence shells. They need only 1 electron to complete their octet, which they do so by sharing of electrons. As a result, they form diatomic gases. Fluorine or chlorine are gaseous, whereas bromine is liquid and iodine is solid. These molecules are held together by weak van der Waals forces, hence fluorine, chlorine are gases. Down the group, the magnitude of van der Waals forces increases and the state changes. The bond dissociation enthalpy value for fluorine is 158.8 kilojoules, whereas for chlorine it's 242.6. and bromine and iodine, it decreases to 192.8 and 151.1 respectively. Now value for fluorine is less than that of chlorine because fluorine atoms face inter-electronic repulsions and bond can be broken easily. But as we move from chlorine to iodine, as the size increases, the bond length increases, the bond dissociation enthalpy decreases. So this is about physical properties of halogens.